effect as a result of these angle measurements on a flat plane and engineered that model, the sphere that you've used, into all sorts of other models. Fair enough. But do you appreciate that your original model, that would be a sphere, had to be derived from a flat plane in the first instance, now that it's been explained by Brian?
I do really not want to get involved in that. I'm sorry.
But that's the crux of your claim. Your claim was that it must start with a sphere. That's how you've started. And we're saying your sphere that you started with had to have a flat plane origin, but you don't want to get into that because it means you'll become a flat earther after you understand it.
Yeah, wise move.
It seems to be mislocating the points as well, which will then mislocate the ground.
Yes, no, I think I know what you understand. So yes, indeed, the first step is I express every coordinate in celestial coordinates, so latitude, longitude, and a distance. And the first thing to notice is that all points on Earth get the coordinates like latitude, longitude, and then 6,000 kilometers.
Right, got you.
Which means the 6,000 is constant, latitude, longitude is only 2 dimensions, so you basically only have a 2-dimensional object. And then to draw it, I use the azimuthal...
Hold on, stop a second.
The azimuthal equations.
Stop a second, stop. You're saying you draw it out in 2 dimensions and then you can take that flat and fold it onto whatever shape you like. Is that what I'm understanding?
No. In terms of the placement of the stars, he has to put them somewhere. Because this is the celestial sphere is infinite, because we're just dealing with angles, no distances. But in this way, when you transpose the coordinates, as far as I can see, the transposition requires a distance for that star to be able to put it in the azimuthal cylinder system. Is that correct?
Mm-hmm. That's correct.
Yeah. So in a way, to transfer it, you have to make an assumption, which is to make the map of the heavens across a flat surface. Is that what you did at 6,000 miles away?
So again, like I said in the beginning, I started from the globe maths, and I just went to look where I could get, and yeah, I ended up where I ended up, showing that it can also produce flat images.
I'm still confused. Hold on. If you're saying you took the globe maths, well, what distance have you got the stars? Have you got them projected out at an infinite distance?
The thing that it says on Wikipedia, basically, that's the thing I've been using. But again, if you have other distances, put them in like you want. I've just been using the globe model. So the sun in this is 120 million kilometers away. Like I said, I've just taken what the physicists use and gone with that. And then you can say, hey, look, physicists, you just made a flat Earth for us. Thank you. I'm not saying you have to accept this. I'm just saying if you start from this physics, from this set of rules, of this set of math, this is where you end up. That's all I'm saying.
Yeah, I think it's brilliant. I'm just trying to clarify them. I've got it on screen for Nathan, your Traloon.com up. So what we've got here is the individual way of determining it, and it's placed. The readings are plotted on your celestial sphere. What he's doing is taking that and transposing the coordinate system into this cylinder instead of a sphere. So we've got a flat plane instead of a globe Earth at the center of this one. So we've transposed it to a flat plane. But in doing so, we can't have everything on the outside because we need stuff in the middle of the cylinder. See, all this covers because it's your sphere of vision. This has now become a physical entity to put things on, but we can't just put it on the edges and the outsides. We've got to put stuff in the middle for the star map to work. So what you have to do is what Tarun was saying was you have to assign a distance for them. So in doing so, you see, this is no longer. You see why it doesn't work for reality, because now we've taken full data
No, because I don't understand how it doesn't. Just you were. I was following along. Keep going.
Okay. So we've now placed the stars, all of them at 6,000 kilometers above the Earth for this data to be able to be transposable onto this system. That's because, and this is an imaginary number. We've made it up.
Hold on.
because,
I'm still sorry if I'm being mathematically illiterate.
No.
Would it not be a cone shape coming off the bottom of this disc at the bottom then? If it was all at the same distance, if they were all at 6,000, then you can't have them.
Wait. Only
Sorry,
the surface of the Earth ends up at 6,000. Everything else ends up at its respective distance. So you transform the entire space, 3D space, into an infinitely high cylinder. That's what's happening. And so the height in the cylinder corresponds to the distance something is away from you.
That's what I asked
So
originally.
if the stars are...
Hold on. That's what I asked originally. So they're at an infinite distance then?
If the stars are infinitely far away, yes. Yes, then.
No, not
the six.
Sorry, no.
Oh.
I'm not suggesting
Or
that's what the
holographic.
stars are.
They have no
I'm
distance.
asking what. I'm not suggesting that's what the stars are. I'm just saying that's how it's being projected. They must be in this description and this projection at an infinite distance. That was originally what I asked.
I'm not sure I understand your question.
Have you generated a full planisphere, star planisphere of both hemispheres? Yeah, from an astronomy point of view, put them over a flat plane that you've raised up 6,000 miles, which is to the center of the Earth, which is where your flat plane center of your ball, which is the position it is sitting at. But then the stars are still out at infinity. There is no real distance to them.
No, what you need to do for the transformation is you draw a sphere through the star. So you take the center of the Earth and you draw a gigantic sphere through the star. So it's going to be humongous. And then you take that sphere and you do the azimuthal equidistant projection. If you do that, your entire sphere will be transformed into a disk. And that's what's put into the cylinder. And azimuthal projection, typically the size goes from, minus pi to pi. I mean, the width is 2 pi. So it's constant regardless the size of your cylinder.
It's like
stars do get compressed if they're higher up. That's correct, yes.
It's like the maps they use when you've got a what do they call it, a planisphere, or what do they call it when they have it dropped over the top?
Yeah, like a record now. So we've got AJC managed to combine the two many years ago with a couple of star issues, but that's the first point. That doesn't work like.
May I interject something?
Yeah.
Before you do, one word.
Adam's
I
getting
just wanted
somewhere.
to summarize
Right,
it all.
Adam's led this conversation for 90% of the actual concise mathematical dissection. Let Adam lead the conversation, please. Go ahead, Adam.
All of these systems in the way when we're looking at sextants and we navigate this Cartesian coordinate system, this sphere of our vision, the way we take this, there is no ball underneath. This is just that sphere of vision. It's in the ball. Remember, the angle change is distance away from you, not rotation of the ball. This is how all of these measurements that we've got that are plotted onto a ball or wherever are obtained off of a flat plane. Now, like I said, it's easy to translocate them onto the inside of a tiny little ball centered in the middle of an infinite celestial sphere. It's easy to put them there, but that's not how they're acquired. It's easy for your mind to think like that. What's happened here is we've got this switch like this, and we've just heard the confusion. And the confusion is we're trying to locate individual measurements and make all of those just fit the translocation onto a map. It can't be done because that's not how these measurements work. They work for us to navigate. They don't work for us to plot, take that plotting and give you a map of the stars to then just move everything down. It only works for the individual. So you've got to cross the two systems unless you go here, which is just to plot it at the center of your celestial sphere. That's right. That's so easy. Right, I've done rambling.
It's a celestial sphere-based projection, and that's what he was doing. Celestial sphere, the apparent sphere, not actual, and then assuming that it is a sphere and then, yeah, maneuvering its mathematics the way it's arranged, the projection of
I
it.
think
Waiting.
Nathan heard it earlier. When he used the coordinates, the longitude and latitude, he used the word 2D coordinates, which makes it a flat plane. I think Nathan heard that earlier too.
Well, that's where we're getting to. That's the conclusion that's about to come. So in terms of your celestial sphere and these angles coming in to your position, the depiction on the left for those watching in the audience that Adam's just detailed, that's the origin. So the misapprehension comes when the guy says, no, I'm starting with a sphere. No, you're not. You're starting with the celestial sphere. That's what's depicted here. And the flat circular disc in the middle is the flat plane that's going to be required to make any angle measurements, to log any of this stuff, to detail any of this stuff, to move forward in any way, shape or form. You need that flat plane in the middle. That's the point.
Thank you, Brian.
Go ahead, Ted.
Number one, why is it taking so long? When he said center of Earth, he needs to prove R. There's no R. So it's over right there. Number two, this was my presentation last week. They're using the equatorial plane because it's flat. And that matches the equatorial celestial horizon at the equator from the celestial presupposed sphere of theirs. So the whole point is they have to use flat to get everything to work. They can't have flat on the surface of a pre-assumed globe. So that's why they always go to the center and say, we're going to use the equatorial plane. We'll do it from there because we can get 90 from there. We can't get it from the surface, so we'll get it from there. Okay, so are they getting it from there? No, no one's going to the center of a presupposed Earth to get anything. So it's the surface. Now, how does the sextant work? Right angles, 90 degree, co-altitude. Can that work on any of what this gentleman said when he said it can work on both models? It can only work on one, a flat. It even works on one, on theirs, a flat equatorial plane, which never actually takes place because it's happening on the surface, which then they take down to the presupposed center of the Earth and say, here's the flat plane that the flat Earth has, but we need to put it here for it to work. This thing is stupid.
Agreed. Good summary.
Well,
Yeah.
Did anyone want to add anything before we go into Brian? Because Brian's got a bit
Just
of a...
before we
I
do,
did.
because I don't want people to be attacking this guy. Because
No, I don't either. Okay, Adam then Eli. Adam, go ahead.
He's come in and if you read his paper, it says it, and he's said it a couple of times. From this stuff, there's no proof for anyone, and I think that should, before people are having a go at him, he's not come in. He happens to be a baller, fair enough, but he's not come in saying this proves anything. He's saying quite the opposite. It doesn't help any perspective.
Yeah,
I'm doing
in
that.
terms of baller
So why go there?
interactions, just before we let Eli go next, this guy's the most, and I'll say it, head and shoulders above any single individual who has come here ever, bar none. So very nice guy, perfectly entitled to his globe belief, and what he's presented and the way he's phrased what he's presented, no issue with any of it. We dealt with a minor issue. QE was right on it. Like, it flies on shit. Good. That's how it should be. Because otherwise I'd have just left it as, no, it's just a flat earther. He just used the wrong words. Not so. Good. It was all addressed. It's all identified. Very nice chap. Thank you. Done a lot of work. He's presented to us very kindly. Got nothing but admiration for the guy. Meanwhile, Eli's got something to say. Go ahead.
I wanted to say about 15 minutes ago, when Brian made the initial point about making angles, which require 90. Well, there's a 90, and you have the co-altitudes and all of this. When he was detailing that, he was detailing how you can't have a curved adjacent, which would be the curving Earth. So I didn't hear you address him directly, and there was a point that was made before that that you answered but didn't address directly then as well. I'm just wondering what you have to say in light of the information that we've been sharing back and forth. We're talking about the angle measurement.
Sure, you'll have to actually address him. True. If you don't, I will. But if you want to concisely address him.
Yeah, so
Yeah.
what's your name?
For me, I'd rather not get into that. That's not the claim I'm making.
You don't want to get into how
That
you'd have a
doesn't
curved
really address
adjacent
me.
to get an elevation angle. That's a shock.
Yeah, that doesn't really address anything either. I've noticed how you've been very careful with not making claims, and it also rubs me in the way that you're saying, well, the information is coming from the fact that we live on a sphere, but you can transpose it to any other shape that you like. But then Adam already addressed that as well. And I'm just wondering if you have any points on the back of any of these addressals to your initial statements.
What I said was, one, we assume the globe model. Then we start working with the globe model and we see where we arrive. For example, if you can arrive at a contradiction, if you can do that, you can say globe model is invalid. So I just assumed the globe model, started working with it, and I ended up that it can actually prove the flat Earth. Well, not prove it, show that it also works.
That's incorrect. You started
That's
with
my
a
only
flat
claim.
plane, and then you reified a globe model.
But let's check if
That's
you understand.
right.
Hold on, everyone. Let's just check if you understand that. Good point, John. So since then, we've gone through how unless you assume you're taking an angle measurement from the centre of a presupposed spherical Earth, what you're actually doing is taking a measurement from a flat plane of your celestial sphere. That's been explained. Is that understood? We're not going to... No, I'll just leave it at that. Is that understood?
I'm using latitude and longitude, yes.
That didn't answer the question.
This might help the situation, right? If you hypothetically stood underneath Polaris, right, at the GP of Polaris, right, GP is geographical position, which is directly underneath Polaris. So directly above Polaris's GP, that's the zenith, Polaris. And you move away from that position, your angle won't be, it'll be 90 at that point, but as you move away, it'll decrease from 90. Now, if you keep moving away till you get to the equator region, it'll go down to about 0, right? But the thing about it is that all that time that you've moved away, every angle you've taken is a right angle. And the base of that right angle is a horizontal plane, because the base of all right angles are horizontal. So every time you've moved away, for no matter what distance you move from Polaris, as long as you can see it and you can take an angle to it, then the baseline of that angle is always going to be horizontal. Now, Polaris will appear to drop in the sky the further you move away from it, until you get to around the equator or just a bit past the equator, and it'll kind of disappear then. But the problem with that is this. If you remove all perspective from that, and then you take your angle that you took on the surface of Earth, and you take that whole thing and put it into the center of a circle, and you then determine that for every angle from that, for every set distance you moved away from the geographical position of Polaris, that as an angle, right, that as an angle to the center of a circle, right, matches, let's say they figure out that 1 degree or 1 degree matches 69 statute miles or 60 nautical miles. Now, it wouldn't have been 60 nautical miles originally because they wouldn't have been using nautical because they didn't exist at the time. But the point is that the globe is back engineered off of flat Earth angles to Polaris. That's why you have an average radius of 3959 miles. So the globe has to start with flat Earth elevation angles. You just remove perspective and then move all your elevation angles to the center of a circle, and you work out how much distance from the ground position, the GP, the geographical position of Polaris, you've gone, and what angle that would be to the center of a circle. And that's where the radius, that's where the radius comes from, the Joule radius, and that's where the circumference, that's where the diameter of the globe Earth comes from. So the globe Earth is a mathematical reinvention that's based off of a flat plane. That's where it actually comes from. And that's why Eratosthenes and Al-Biruni after him had to revert to the mathematics of Pythagoras. And what mathematics were they reverting to? What is Pythagoras famous for? The right angle. So it's just a back engineering based off of a flat plane.
So for Trulin, which is to say, originally, fair enough, you've taken the model that has taken effect as a result of these angle measurements on a flat plane and engineered that model, the sphere that you've used, into all sorts of other models. Fair enough. But do you appreciate that your original model, that would be a sphere, had to be derived from a flat plane in the first instance, now that it's been explained by Brian?
I do really not want to get involved in that. I'm sorry.
But that's the crux of your claim. Your claim was that it must start with a sphere. That's how you've started. And we're saying, no, your sphere that you started with had to have a flat plane origin. But you don't want to get into that because it means you'll become a flat earther after you understand it.
Yeah, wise move.
No, because it's against, like I said, I think I haven't discredited the globe, far from it. I just believe you can view the world. It's possible to view them in both ways. That's my position.
And that's correct. You can.
And all I've done in the beginning is I've said
that's
my
right.
claim
You've said
was...
that 3 times. I understand your position. You can. And based on your modelling, you can take the globe position and remodel it to be flat. But to have either to be considered in any way, you had to start with flat, but you don't want to get into that. To have either reconsidered in either way, both started with a flat plane and then were derived afterwards. But you don't want to get in. I don't get it. Why don't you want to get into that? That's the crux of the argument.
Because I started from step 1. We assume globe physics. We start from there. And then we use latitude and longitude. And if you derive that from a flat plane, that's fine for me.
I get that. But no, you're incorrect. Because no, when you say you started with globe physics, no, you didn't. The origins go back further, and we've now enlightened you to how your, quote, globe physics actually started with a flat plane, but you don't want to get into it. You mean you don't want to concede that what you think is the start point, that's globe physics, is wrong. It's actually flat Earth starting point. You don't want to just concede that, because that's where we're at. It seems unreasonable that you wouldn't concede it when we've taken the time to explain your misapprehensions of the starting point. The starting point's flat, my friend. Why won't you just concede that? We've explained it in detail, taken our time with you. It seems unreasonable that you wouldn't just say, yes, I understand how the origins can only be flat. Why wouldn't you concede that? Are you an unreasonable man?
Because I'm not going to decide that here and now on the show. It's going to take time and I'm going to read all the arguments, and I don't know what. That's not something that's going to happen here.
That's fair enough.
And Arwin, okay, make your comment, but I just want to round out this point. Because you've been such a nice guy, and without seeming in any way weaselly, you've subverted it in such a reasonable way that I'm going to fold and say, fair enough. I was going to do it earlier, but you've now taken every bit that anybody else wanted to throw at you. Kudos, you've been the nicest. Reiterate it. You've been one of the nicest globe-believing guests we have ever have, if not the most reasonable. So thank you very much.
Wrong again.
Agreed.
Wrong again.
I agreed, and I wanted to make a very, very quick comment.
Go, because Arwin will rumpus everybody.
Right, yeah,
go ahead.
Yeah. So you call it globe physics, but I think that's a misassumption from your perspective. It's actually celestial sphere physics.
Yeah,
that's what your vantage point. It's because of the celestial sphere, not the Earth sphere.